The Great Pyramid of Giza holds a secret language in its stones. This is not a metaphor. Ancient builders across the world embedded precise mathematical codes into their monuments, a silent numeric language waiting to be read. From the jungles of Cambodia to the plains of England, these structures challenge everything we think we know about early history. By the end of this exploration, you will see the ancient world not as a collection of ruins, but as a sophisticated library written in geometry and stone. We will uncover how the Parthenon whispers the golden ratio, how Stonehenge tracks the cosmos, and why a city in Mexico might be a giant calendar. What single idea connects a pyramid, a stone circle, and a marble temple across thousands of miles and years? The answer lies in a forgotten science, a code that turns monuments into messages. What does it mean if our most distant ancestors understood the universe in a way we are only now relearning? This numeric language is the first clue to a much larger mystery. To understand it, we must step back and ask a fundamental question. What exactly is a mathematical code carved in stone? It is not a secret message written in numbers for someone to simply read. You will not find an equation chiseled above a temple door. Instead, this code is the structure itself. It is the silent grammar of its design, a consistent and intentional use of mathematical principles that govern every proportion, every angle, every alignment. Think of it as the architectural equivalent of a musical scale. A composer does not write the words C major scale on the sheet music. They use the notes and relationships inherent to that scale to create harmony. In the same way, ancient builders used mathematical relationships as their foundational scale to create harmony in stone. This code manifests in several profound ways. The most common are precise numerical ratios. These are not rough estimates. They are recurring, exact proportions that appear again and again in structures separated by continents and centuries. Two ratios in particular echo through history like a refrain. One is pi, the constant that defines the relationship between a circle's circumference and its diameter. The other is known as the golden ratio, often represented by the Greek letter phi. This is a special number, approximately 1.618, that appears when a line is divided so that the ratio of the whole to the larger part is the same as the ratio of the larger part to the smaller part. It is found in seashells, flower petals, and, intriguingly, in the very proportions of the human body. When this ratio appears in architecture, it creates a sense of balance and beauty that feels instinctively right to us. Beyond these ratios, the code includes the use of sacred geometric shapes, perfect circles, squares, and triangles that hold symbolic meaning. And it extends to precise astronomical alignments, where doorways, corridors, or entire complexes are oriented to capture the light of the sun or moon on specific days, turning the building into a giant calendar or celestial observatory. So why encode this knowledge? The purpose was likely multifaceted. It could have been a form of religious symbolism, a way to embody cosmic order in a physical temple. It could have been practical, for creating perfect acoustics for rituals or ensuring structural stability that has lasted millennia. Or it could have been a way to preserve and transmit vital knowledge about time, mathematics, and the heavens in an age before widespread writing. This foundational idea that these monuments are built on a deliberate, sophisticated mathematical template is the master key. It transforms a pile of stones into a purposeful message, and a silent ruin into a page from a forgotten textbook. With this key in hand, we can now approach our first monument not just as tourists, but as interpreters, ready to listen to what its geometry has been trying to say for thousands of years. That silent numeric language speaks its first clear word in the shape of a perfect circle, Across the ancient world, from the deserts of Egypt to the green hills of Britain, one mathematical constant emerges from the stones again and again: pi. This is the fixed relationship between a circle's circumference and its diameter, a number beginning 3.14159 that continues infinitely without pattern. Its appearance in these monuments is not a coincidence of rough measurement. It is a deliberate, encoded signature. Take the Great Pyramid of Giza. If you take the perimeter of its square base and divide it by twice its original height, the result is not a random figure. It is a number extraordinarily close to pi. This suggests the builders designed the pyramid's proportions to embody this constant, using a concept of circular geometry within a four-sided structure. It is a mathematical sleight of hand, a circle squared in stone. Then shift your gaze thousands of miles to the west to the Salisbury Plain. Stonehenge at its heart is a series of concentric circles. The outer Sarsen circle, those towering uprights capped by lintels, forms a near-perfect ring. The very act of creating such a massive, precise circle from multi-ton stones implies a profound practical understanding of pi. They had to calculate the circumference, shape the curved lintels, and arrange the megaliths to close the ring perfectly. This knowledge is echoed in circular temple foundations from Mesopotamia to the Americas. So why was this particular constant so vital? For countless ancient cultures, the circle was the ultimate symbol. It represented the sun and the moon, the cyclical journey of the seasons, the eternal loop of life and renewal. It was perfection, infinity, and the heavens themselves. By encoding pi into their most sacred structures, the builders were doing more than demonstrating clever mathematics. They were performing an act of cosmic harmony. They were attempting to align human creation with the perceived mathematical perfection of the universe, to make their temples and observatories resonate with the same principles that govern the stars. This makes pi more than just a number found by accident. It becomes a universal signature, a shared piece of intellectual furniture discovered independently across the globe. It tells us that when these early engineers looked at the world, they saw not chaos but geometry, and they sought to replicate that divine geometry in the very foundations of their world. If pi was the universal signature, then the golden ratio was the ancient world's aesthetic obsession. This principle, often represented by the Greek letter phi, is a specific and elegant proportion. Imagine a line divided into two parts. The golden ratio occurs when the ratio of the entire line to the longer segment is exactly the same as the ratio of that longer segment to the shorter one. This creates a number, approximately 1.618, that seems to hold a unique power. It is not just a mathematical curiosity. You can find it in the spiral of a nautilus shell, the arrangement of seeds in a sunflower, and the sweeping arms of distant galaxies. It is a pattern woven into the fabric of the natural world, a rhythm of growth and form, and the ancients did more than just notice it. They revered it as a divine proportion, a visual echo of cosmic harmony, and they deliberately encoded it into their most sacred spaces. The Parthenon in Athens stands as perhaps the most famous architectural example. While the temple has faced the passage of time, analysis of its original design reveals that its iconic facade fits almost perfectly within a golden rectangle. The relationship between the building's height and width, the spacing of its columns, all seem to adhere to this sacred ratio. It was a conscious choice, an application of natural beauty to marble, meant to evoke a sense of perfect, timeless balance. This pattern repeats across the globe. The Great Pyramid of Giza's internal geometry, the proportions between its chambers and passages, also incorporates phi. It appears in the layouts of temples from India to Central America. Why this relentless pursuit of one specific number? The answer lies in observation and aspiration. Ancient philosophers and builders studied the natural world intently. They saw this ratio in the very patterns of life, in the way a fern unfurled or a pine cone scales arranged themselves. They interpreted this not as random chance, but as the visible handwriting of a creator, the mathematical blueprint for beauty and vitality. To replicate this proportion in stone was to participate in that divine order. It was an attempt to infuse a static, human-made structure with the dynamic, living perfection of nature itself. A temple built with fire was not merely a building. It was a conduit designed to resonate with the same fundamental principle that shaped galaxies and flowers, aiming to bring those who entered into harmony with the universe. This transforms our understanding of their intent. They were not just stacking stones to create shelter or even to honor gods. They were engaged in a profound act of philosophical and spiritual engineering, using mathematics as their sacred language to write ideals of eternal beauty directly into the landscape. But geometry and proportion were not the only languages written in stone. The sky itself was their ultimate reference, a vast, moving clockwork of stars and planets. For ancient societies, the positions of the sun, moon, and stars were not just lights in the night. They were the celestial clock and calendar that dictated the rhythm of life, telling them when to plant, when to harvest, and when to hold their most sacred ceremonies. To encode this celestial knowledge into a monument was to perform a kind of magic. It was an attempt to freeze time, to capture the precise moment of a solstice sunrise or a star's rising and lock it permanently into the landscape. This is where the mathematical code transcends pure numbers and becomes a dynamic, living record of the cosmos. Consider Stonehenge standing silent on the Salisbury Plain. On the morning of the summer solstice, the longest day of the year, if you stand at the center of the stone circle and look toward the heel stone, you will witness the sun rise directly over it. This is not a lucky accident. It is a deliberate, engineered alignment, a stone calendar marking a pivotal point in the solar year. This single alignment transforms the entire structure from a mysterious ring of rocks into a sophisticated astronomical instrument. The builders had to observe the sun's path for generations, note its northernmost rising point, and then physically translate that celestial data into a fixed terrestrial marker using multi-ton stones. It is observational science made permanent. This practice of celestial encoding reaches a breathtaking scale in ancient Egypt. The Great Pyramid of Giza is not only a geometric marvel but also an orienteering one. Its four sides are aligned with the cardinal directions north, south, east, and west with an accuracy that still astounds surveyors today. The deviation is minuscule, a fraction of a single degree. Achieving this required an immense understanding of the stars, likely using the circumpolar stars that never set to find true north. Some researchers have proposed an even more ambitious celestial blueprint. They suggest the layout of the three main pyramids at Giza mirrors the three stars of Orion's belt, a constellation deeply significant in Egyptian mythology as the realm of Osiris, god of the afterlife. Whether this specific correlation is intentional or symbolic, it highlights the profound desire to create a terrestrial map of the heavens. Further south at the Temple of Karnak, the alignment serves a ritual purpose. The main temple axis is oriented so that on specific feast days, the rising sun would shine directly down the long avenue of columns, illuminating the inner sanctuary where the statue of the god Amun-Ra resided. Imagine the impact of that moment. After a long procession in the pre-dawn dark, the first rays of the sun would come streaming through the temple gates, traveling down the hall like a beam of divine light to awaken the god. This was astronomy in service of awe, a calculated theatrical event designed to demonstrate the pharaoh's connection to the solar cycle itself. These alignments are far from random. They represent generations of accumulated observational data, a complex understanding of celestial mechanics translated into fixed, monumental form. They are a permanent record of the cycles that governed everything: agriculture, religion, and the very legitimacy of power. By building these celestial codes, our ancestors were not just watching the sky, they were building a bridge to it, crafting stones that could speak the language of the stars. The silent language of the stars and sacred ratios required one more crucial element to become a global phenomenon, a shared system of measurement. How could builders separated by oceans and centuries possibly create structures that echoed the same mathematical principles? The answer may lie not in the stars, but in something far more personal, a universal yardstick. While cultures developed their own units, like the Egyptian royal cubit, a fascinating proposal suggests some may have shared a common standard. This idea centers on the work of an Oxford engineering professor named Alexander Thom. In the mid-20th century, Thom surveyed hundreds of stone circles and megalithic sites across Britain and France. He was not looking for ghosts or ley lines. He was taking precise measurements, and the data revealed a startling pattern. The diameters of these circles, the distances between stones, they were not random. They appeared to be multiples of a single recurring unit. Thom called it the Megalithic Yard. He calculated its length at approximately 2.72 feet or 83 centimeters. This was not a rough estimate. His analysis suggested it was used with a consistency of about plus or minus 1 millimeter across sites separated by hundreds of miles. Imagine the implication. From the remote Scottish islands to the coast of Brittany, different communities, perhaps over centuries, were laying out their sacred circles using the same basic measuring rod. This points to something far more organized than isolated groups of farmers dragging stones. It hints at a transmitted system of knowledge, a school of thought, or a guild of surveyors who carried this standard with them. They were not just building monuments, they were replicating a precise template, scaling geometric designs according to a shared code. This concept of a universal measure finds a parallel in the ancient world's most famous unit, the Egyptian cubit. Unlike the speculative megalithic yard, the cubit is well documented. It was based on the human body, specifically the length from the elbow to the tip of the middle finger. But the Egyptians did not stop there. They refined it into a precise standard, the royal cubit, which was divided into 7 palms and 28 digits. This measurement was not arbitrary. Some researchers believe it was derived from astronomical observations, perhaps linked to the size of the Earth or the arc of the celestial sphere. The cubit was the fundamental tool behind the pyramid's breathtaking precision. It was the ruler that translated architectural plans into reality on a gargantuan scale. So, what does the potential existence of these standardized units tell us? It transforms these monuments from impressive feats of brute strength into masterpieces of coordinated intellectual effort. A common unit of measurement is the bedrock of complex society. It allows for planning, for division of labor, and for the faithful reproduction of design across generations. Whether it was the megalithic yard or the royal cubit, these measures were more than tools. They were carriers of the code itself. They ensured that the sacred geometry, the solar alignments, the proportions echoing phi, could be accurately transferred from mind to marker, from one generation to the next, and possibly from one culture to another. This shared language of length made the global conversation in stone not just possible, but deliberate. Geometry gave them the shapes, and measurement gave them the scale, but to turn a vision on the ground into a perfect square or a true right angle required one more ingenious tool. This brings us to a principle so fundamental it seems to belong to the classroom, not the ancient quarry, the right triangle, and specifically sets of numbers known as Pythagorean triples. The familiar equation, a squared plus b squared equals c squared, is credited to the Greek philosopher Pythagoras, who lived around 2,500 years ago. Yet the stones tell a different story, one where this mathematical rule was a working tool millennia before it ever had a name. A Pythagorean triple is simply 3 whole numbers that perfectly satisfy that equation. The most famous is 3, 4, and 5. If you create a triangle with sides in that proportion, you are guaranteed a perfect 90-degree angle opposite the longest side. This is not abstract theory. It is a practical, foolproof method for creating a true right angle using nothing more than a knotted rope. A builder could take a cord with 12 equally spaced knots, form a triangle with sides of 3, 4, and 5 segments, and instantly have a perfect corner for their temple's foundation. The evidence that ancient engineers used this knowledge is written in the monuments themselves. Look at the king's chamber deep within the Great Pyramid. The dimensions of this granite room are not random. Researchers have shown that its proportions can be expressed using the numbers 2, the square root of 5, and 3. This forms another Pythagorean triple, a more complex one, demonstrating a grasp of the principle that goes beyond the simple 3-4-5 triangle. It shows a fluent, applied understanding of the relationship between squares and sides. This use of encoded right-angle geometry was likely widespread. Imagine the challenge of laying out the vast, perfectly square base of a pyramid or the precise rectangular foundation of a temple complex over uneven ground. Eyeballing it was not an option. Using the stars for cardinal alignment gave you one true direction, but to create the perpendicular lines needed for a square, you needed a geometric guarantee. Pythagorean triples provided that guarantee. They were the ancient world's ultimate surveying tool, a mathematical trick that transformed a length of rope into a precision instrument. This shifts our perspective entirely. It means the breathtaking precision we see, the corners that meet at exact 90 degrees, the sides that run perfectly parallel, did not come from guesswork or supernatural aid. They came from a deep, working knowledge of mathematical relationships. The builders were not just stacking stones according to a holy vision. They were following a calculated blueprint, using numerical codes to ensure that every angle was true and every wall was straight. This practical grasp of geometry, embedded silently into the construction process, is perhaps one of the most profound codes of all. It speaks not of mysticism, but of methodology, of a forgotten standard of engineering excellence that allowed these cultures to build not just for their time, but for eternity. The Great Pyramid of Khufu stands as the ultimate testament to this encoded language. It is not merely a tomb, it is a masterclass in applied mathematics carved in limestone. Every proportion, every angle, every alignment whispers a different part of the same complex equation. Start with its most famous geometric whisper. If you take the pyramid's original base perimeter and divide it by twice its height, the result is a figure astonishingly close to pi. This suggests the builders conceived of the pyramid's shape as a representation of a circle's properties projected onto a square base, a profound synthesis of forms. Then consider its orientation. The four sides are aligned to the cardinal directions with a precision that still baffles engineers. The north-south axis deviates from true north by less than 1/12 of a single degree. Achieving this over 13 acres of bedrock required an intimate, generational knowledge of the stars, likely using the circumpolar stars as a fixed celestial clock to find that perfect bearing. But the code runs deeper than the exterior. The dimensions and angles of the internal passages, like the long, sloping descending corridor and the grand gallery, are not arbitrary. Some researchers propose their lengths correspond to specific time cycles, such as the solar year, or that their slopes were calculated to pinpoint celestial events when observed from within. The king's chamber itself, built from immense blocks of granite, exhibits proportions based on a Pythagorean triangle, embedding that right-angle geometry at the heart of the structure. This layering of codes, geometry atop astronomy atop precise measurement, points to a unified and sophisticated blueprint. The mathematical intent expands when you view the pyramid not in isolation, but as part of an ensemble. The arrangement of the three main pyramids of Giza on the plateau is geometrically harmonious. Their positions relative to one another and to the nearby Nile River seem to follow deliberate, interlocking patterns. This has led to compelling, though debated, theories that the entire complex is a terrestrial map. One proposal suggests the layout mirrors the three stars of Orion's belt, tying the pharaoh's eternal resting place to the realm of the gods. Another, even more expansive idea posits that the scale of the Great Pyramid, combined with its latitude on Earth, creates a model where its perimeter relates to the planet's circumference and its height to the polar radius. Whether these grand correlations were intentional or symbolic, their very plausibility underscores a central truth. The Giza Plateau represents a concentration of mathematical and astronomical knowledge so dense, so intentionally applied, that it feels less like a cemetery and more like a three-dimensional textbook. It is a pinnacle of architectural intent, a silent symphony composed in stone, waiting millennia for us to learn how to listen. Stonehenge stands as a Neolithic computer under the open sky. Its iconic silhouette of towering sarcens is not a random arrangement but a complex geometric puzzle written in granite and bluestone. The design is a nested series of shapes, concentric circles, and inner horseshoes, connected by processional avenues that stretch toward the horizon. This layout is the physical code. The proportions between these circles are not haphazard. Researchers note that the diameters often relate to each other through simple integer ratios, like 1:2 or 3:4. These clean, whole number relationships suggest a blueprint based on fundamental geometric principles, a deliberate choice to create harmonic space. The astronomical alignments are the most famous part of this code. The axis of the monument points to the summer solstice sunrise and the winter solstice sunset, turning the entire structure into a giant stone calendar that marks the year's pivotal turns. But the geometry may run even deeper. Some surveys of the site have revealed that key points around the circle's perimeter align in ways that suggest the use of advanced Pythagorean triangles, like the 5-12-13 triangle, to lay out precise right angles and alignments. This knowledge would have allowed the builders to plot the complex positions of the stones with astonishing accuracy. Consider the engineering of the lintels, the horizontal stones that once crowned the outer circle. To create a continuous, gently curved ring from these massive blocks, each lintel had to be meticulously shaped. The ends were carved with tongue and groove joints, and the undersides were subtly curved so that when placed atop the slightly leaning uprights, they would form a smooth, level circle. This required a sophisticated understanding of arcs, angles, and three-dimensional fitting. So what was this stone computer calculating? It tracked the solar year, certainly, guiding agricultural and ceremonial cycles. But its function was likely more profound. By encoding celestial events into a permanent, terrestrial form, Stonehenge served as an interface with the cosmos. It transformed the abstract, moving sky into a fixed, sacred geometry that people could walk within and touch. The ceremonies held there during the solstice sunrise would have been a powerful fusion of architecture, astronomy, and belief. The light piercing through the stones at a preordained moment was not just a spectacle. It was the code executing, the monument proving its connection to a larger cosmic order. This transforms Stonehenge from a mystery into a message. It is a testament to a society that observed the heavens with precision and possessed the geometric language to build their understanding into the very bones of the land, creating a timeless dialogue between earth and sky. While Stonehenge spoke the language of earth and sky, the ancient Greeks aimed to capture the very essence of beauty in stone. The Parthenon, standing in white marble majesty on the Acropolis, is often hailed as the pinnacle of classical architecture. Its power lies not just in its grandeur, but in a subtle, almost invisible perfection that the eye senses before the mind understands. Modern analysis has peeled back the layers of time to reveal the secret of its harmony. The golden ratio, phi, is woven into its very fabric. The relationship between the temple's width and its height conforms to this divine proportion. The spacing between its 46 majestic Doric columns is not uniform in a boring sense. It is rhythmically varied according to phi, creating a visual cadence that feels both dynamic and perfectly still. Even the intricate sculptural details of the frieze and pediments are believed to follow this same proportional rule. This was no happy accident of construction. It was a deliberate philosophical choice. The sculptor Phidias, who oversaw the temple's artistic program, was a known proponent of these mathematical ideals. For the Greeks, beauty was not a matter of subjective taste. It was an objective truth rooted in the order of the cosmos. They observed phi in nature, in the spiral of a shell, and the proportions of a human form they considered ideal. To replicate it in architecture was to participate in a universal law. The Parthenon was more than a house for the goddess Athena. It was a physical manifesto. It declared that human reason, through mathematics, could perceive and recreate the harmonic principles that governed the universe. Every column, every metope, was a syllable in an argument written in marble, an argument that true beauty arises from immutable mathematical truth. When you stand before it, even in ruin, you are not just looking at a building. You are witnessing a civilization's attempt to freeze a moment of perfect intellectual and aesthetic clarity, to make the invisible geometry of the cosmos permanently visible. Across the Atlantic, another civilization wrote its cosmic vision not on a single monument, but across an entire city. Teotihuacan, the sprawling metropolis in the Valley of Mexico, is a masterwork of measured harmony. Its very name, given by the later Aztecs, means the place where the gods were created. Walking its grand avenue of the dead, flanked by massive pyramids, you are not just in an archaeological site. You are inside a three-dimensional model of a universe governed by number and ritual. The city's genius lies in its unified design. Unlike the organic growth of most ancient cities, Teotihuacan feels planned from the ground up with a single, breathtaking geometric vision. The central axis, the Avenue of the Dead, runs for miles, but it does not point true north. Instead, it is aligned 15.5 degrees east of north. This was no surveying error. Researchers believe this precise orientation was chosen to track the Pleiades star cluster as it set on the horizon, or to align with a sacred mountain. Every step down this vast corridor was a journey along a celestial pathway. The distances between the city's colossal structures are where the mathematical code becomes audible. The Pyramid of the Sun, the Pyramid of the Moon, and the Temple of the Feathered Serpent are not placed at random intervals. Measurements reveal that these distances are often multiples of a standard unit, and these numbers are not arbitrary. They echo the sacred numbers of Mesoamerican timekeeping. The 260-day ritual calendar and the 365-day solar year were the heartbeat of their world. Evidence suggests key distances in the city plan correspond to these numbers or their ratios when measured in their local unit, the Teotihuacano unit. For example, the distance from the Pyramid of the Sun to the Temple of the Feathered Serpent might be a multiple of 260, weaving the ritual calendar directly into the urban fabric. This turns the city into a giant, walkable clock, but the code is also written in the pyramids themselves. The slope angles, the volumes, the proportions of their tiers all appear calculated. Some analyses suggest the base perimeter of the Pyramid of the Sun relates to its height in a way that encodes pi, much like the Great Pyramid of Giza. Others see in the complex, layered facade of the Temple of the Feathered Serpent a representation of their calendar cycles and cosmological beliefs. The entire city then becomes a physical manifesto. It was a deliberate attempt to create a microcosm, a perfect earthly reflection of a mathematically ordered cosmos. To live in Teotihuacan was to inhabit a model of reality, where every journey down the avenue of the dead reinforced one's place in a universe measured, timed, and sanctified by geometry. This was not merely urban planning, it was the ultimate act of philosophical engineering, building a world where stone and space whispered the eternal numbers of the gods. But this grand narrative of a global mathematical language faces a powerful and necessary challenge. When we look at these ancient stones, are we truly seeing a deliberate code, or are we simply finding patterns we want to see? This is the core of the controversy, a critical divide between coincidence and intentional design. Skeptics offer a compelling counterargument. They suggest that given enough measurements on a large, complex structure, you can inevitably find numbers that seem significant. If you search long enough through the proportions of any building, you will eventually stumble upon something close to pi or phi, or a pleasing whole number ratio. This tendency is known as apophenia, the human instinct to perceive meaningful connections within random or unrelated data. It is the same impulse that lets us see faces in clouds or constellations in stars. Applied to archaeology, it means we might be projecting modern mathematical expectations onto ancient builders who had entirely different intentions. The margin for error in ancient construction was real. Quarrying, transporting, and placing multi-ton blocks without modern machinery inevitably introduced small imperfections. Could the apparent presence of pi in the Great Pyramid simply be a result of the chosen slope angle, a practical engineering decision that accidentally produces a familiar number? Could the alignments at Stonehenge be close enough to the solstice sunrise that a community, over generations, simply decided that spot was sacred rather than calculating it with precision? These are not dismissive questions, they are essential for rigor. To move from intriguing speculation to credible theory, the evidence must withstand this scrutiny. The case for intentional design strengthens not from a single coincidence, but from a web of consistent evidence. First, we look for repetition. Finding the golden ratio in one temple could be chance. Finding it encoded in the proportions of temples, sculptures, and city plans across an entire culture, as in ancient Greece, points to a shared aesthetic principle. Second, we examine cultural context. Did this society possess the mathematical knowledge to make such a design possible? We know the Egyptians had advanced arithmetic and geometry for land surveying. We know the Maya had a complex calendar system and concept of zero. This context makes the leap from abstract knowledge to architectural application not only possible, but likely. Finally, we consider practical impossibility. Some feats are simply too precise to be accidental. Aligning the Great Pyramid sides to true north within a fraction of a degree, using the technology of the time, required deliberate, sophisticated astronomical observation. It cannot be explained away as a lucky guess by builders just trying to make a stable mound. This debate is not a sterile academic exercise. It is the process that separates romantic legend from historical insight. By engaging with the skeptic's arguments, we are forced to sharpen our own. We must look beyond a single, cherry-picked measurement and seek the consistent, practical application of a principle across an entire monument or culture. It pushes us to ask not just what the numbers are, but why they would be used and how they could be achieved with the tools at hand. In doing so, we move closer to hearing the true voice of the past, distinguishing the clear signal of intentional design from the background noise of coincidence. The precision we see is not a product of magic, but of a profound and practical intelligence. To understand how abstract codes became stone reality, we must look at the hands that did the work and the simple tools they wielded. Without satellites or steel, they achieved feats that still command our respect. Their toolkit was a masterpiece of applied ingenuity, transforming everyday materials into instruments of extraordinary accuracy. Consider the humble rope. In ancient Egypt, surveyors known as harpedonapti or rope stretchers were the key technicians of this precision. A knotted cord was not just for measuring distance. By using knots to mark specific lengths, they could create perfect geometric shapes right on the ground. To lay out a true right angle for a pyramid's corner, they would use the 3, 4, 5 triangle principle. They would take a rope with 12 equally spaced knots, stretch it to form a triangle with sides of 3, 4, and 5 segments, and the angle opposite the 5-segment side would be a perfect 90 degrees. This simple act, repeated across vast construction sites, guaranteed the flawless square bases we marvel at today. For aligning those bases to the cardinal directions, they turned to the sky and used sighting poles. By observing the rising and setting points of specific stars over many nights, they could establish a true north-south line. Placing a series of poles along this sight line, sometimes over great distances, allowed them to transfer that celestial bearing directly onto the desert floor. Establishing a level plane for foundations on uneven ground presented another challenge. Their solution was elegant in its simplicity: the water level. A shallow trench filled with water or two connected vessels creates a perfectly horizontal reference line regardless of the terrain's slope. By marking equal heights on posts set in the water, they could ensure that every corner of a massive temple complex started from the same flat datum. Some researchers even suggest the use of polished metal or obsidian mirrors as primitive optical devices to reflect sunlight over long distances for alignment checks. This practical knowledge was not stored in textbooks, it lived in people. The transmission of this complex code likely happened through a master-apprentice system, a continuous chain of hands-on learning. The principles of sacred geometry and celestial observation were probably woven into the fabric of rituals, myths, and songs. A story about a god measuring the heavens might encode a surveying technique. A ceremonial dance might trace out the path of the sun at the solstice. This made the knowledge both sacred and practical, protected and perpetuated through cultural memory. It was an empirical science refined over generations. A master builder did not just know the number pi, he knew the feel of the rope that produced the correct slope. He did not just know the date of the solstice, he knew the exact notch on the horizon where the sun would appear. This intimate, accumulated wisdom, passed down through touch and tradition, allowed them to bridge the immense gap between a mathematical idea and a mountain of stone. Their genius was not in having secret technology, but in using profound observation and simple physics to make the invisible codes of the universe permanently, visibly true. This perspective transforms every measurement into a prayer. For the builders, the circle was not just a shape, it was infinity made visible. The square was not merely a stable base, it was the symbol of the ordered material world. And the triangle pointing upward was the sacred bridge between the two, the path of ascension. These were not abstract concepts in a geometry lesson. They were the fundamental glyphs of a spiritual reality, and building with them was the highest form of devotion. When an Egyptian architect laid out a pyramid's square base, he was anchoring the pharaoh's spirit to the earth. When he calculated the slope to form 4 perfect triangles meeting at a point, he was constructing a ramp for that spirit to climb to the stars, to join the eternal, circular journey of the sun god Ra. The mathematics was the ritual itself. This sacred language of form is echoed globally. In Hindu temple architecture, the entire design is governed by the Vastu Purusha mandala, a complex geometric diagram that maps the cosmos and the body of the divine onto the temple floor plan. Every proportion, every chamber's placement is dictated by this spiritual mathematics, meant to align the worshipper with cosmic order. Similarly, the mandalas of Buddhist tradition are intricate geometric representations of the universe, used as tools for meditation to guide the mind from the earthly square to the cosmic circle. The numbers themselves held power. The number 4 represented the cardinal directions and the stability of the world. 7 often corresponded to the known celestial bodies, the wandering planets. The number 12, as in the 12 months or the 12 signs of the zodiac, symbolized completed cycles. By encoding these numbers into a structure's dimensions, say, using 12 pillars or 4 gates, the builders were invoking the qualities of those cycles, weaving the essence of time and space into the sanctuary. This is why the mathematical codes are so much more than engineering. They are a profound theological statement written in stone. They tell us across millennia that these cultures saw the universe not as chaotic, but as beautifully, terrifyingly ordered. They believed that by understanding and replicating that order through sacred geometry, they could participate in it. A temple built to the golden ratio was not just aesthetically pleasing, it was a vessel tuned to the frequency of creation. A pyramid aligned to true north was not just a feat of surveying, it was an axis mundi, a world pillar connecting heaven and earth. The ultimate goal was harmony, to bring human endeavor into resonance with the cosmic symphony. So when we look at these monuments and see pi or phi, we must remember we are not just decoding an ancient calculator, we are reading their scripture. We are listening to their deepest belief that mathematics was the native tongue of the gods, and that by speaking it in stone, they could touch the divine. This celestial language, however, is not one we can translate with a single key. To truly hear what the stones are saying about the stars requires a new kind of listener, a scholar who is part archaeologist, part astronomer, and part detective. This is the realm of archaeoastronomy, a field born from the simple, powerful question: what did the sky mean to them? It moves beyond admiring a solstice alignment to meticulously reconstructing the entire celestial landscape of the past, seeking the stories written in both earth and ether. The work begins not with telescopes pointed upward, but with total stations and laser scanners mapping the ground with millimeter precision. Every stone's position, every doorway's orientation, every subtle incline is recorded. This creates a digital twin of the monument, a perfect frozen snapshot of its geometry. Then, the archaeoastronomer turns to sophisticated software planetariums for the ancient world. These programs can wind back the cosmic clock, accounting for the slow wobble of Earth's axis over millennia, to recreate exactly which stars shone above a given temple on the night of its dedication, or where the moon rose on a significant date 3,000 years ago. This fusion of dirt archaeology and digital astronomy is the only way to test alignment theories with any rigor. It separates compelling patterns from wishful thinking. The field has evolved dramatically from its early focus on dramatic solar events. While solstices and equinoxes remain vital, researchers now probe for more subtle, complex targets. They investigate lunar standstills, the points where the moon reaches its extreme northern and southern risings over an 18.6-year cycle, a pattern that requires generations of observation to comprehend. They search for alignments to the heliacal rising of specific stars, like Sirius in Egypt or the Pleiades in Mesoamerica, events that mark the beginning of seasons or sacred years. Some of the most intriguing proposals suggest entire constellations were mapped onto the ground. The correlation of the Giza pyramids with Orion's belt is one famous, though debated, example. In the American Southwest, patterns of stone circles and cairns are studied as potential representations of star patterns significant to Puebloan cultures. This transforms a site from a single-purpose calendar into a celestial storybook. A line of stones might not just point to a star, it might trace the path of a hero from mythology as he journeys across the heavens. Archaeoastronomy provides the essential cipher, the Rosetta Stone that allows us to translate static, earthly positions into dynamic, celestial narratives. It reveals that these codes were not just about marking time, but about embedding myth, authority, and a profound sense of place within the grand, turning vault of the sky. The stones are fixed, but the stories they tell are written in the movement of light across millennia. This shared language of stone and stars presents a haunting question. How could cultures separated by vast oceans and thousands of years arrive at the same sophisticated principles? The transmission of this knowledge is the great enigma at the heart of our story. On one hand, we have the compelling evidence of parallel discovery, the human mind observing the same sun, the same moon, and the same geometric patterns in nature could independently stumble upon these truths. A builder in Egypt looking at the night sky and a priest in Mexico tracking the seasons were both solving the same cosmic puzzle, using the tools of observation and reason available to them. The golden ratio appears in natural forms everywhere, from a nautilus shell to the spiral of a galaxy. It is entirely plausible that artists and architects in Greece and in Cambodia, each seeking an ideal of beauty, would separately identify this proportion as inherently pleasing and worthy of inclusion in their sacred spaces. This view celebrates the universal spark of human ingenuity, a testament to our shared capacity for discovery when faced with the same physical world. Yet the consistency and precision give pause. The use of Pythagorean triples for creating perfect right angles, or the specific alignment of monuments to track complex lunar cycles, feels less like a natural intuition and more like a taught technique. This has led to a more controversial line of thought, the idea of a common source. Some propose the existence of a lost primordial civilization, an advanced culture whose knowledge survived its own end and was carried across the globe by its survivors, seeding these ideas wherever they went. Others suggest more gradual but still tangible lines of transmission through ancient trade routes or forgotten maritime connections that could have allowed ideas to travel between what we think of as isolated worlds. The truth likely resides in a fascinating middle ground. While direct contact between, say, the builders of Stonehenge and the architects of Teotihuacan seems improbable, we must not underestimate the interconnectedness of the ancient world. Knowledge could flow along chains of contact, passed from culture to culture over centuries, adapting and evolving with each new hand that held it. A mathematical concept discovered in Mesopotamia might travel to India, then to Southeast Asia, changing form but retaining its core principle, like a story told and retold until it becomes part of a new tradition. This was not a single lost civilization, but perhaps a slow, diffuse network of shared discovery, where breakthroughs in one region eventually rippled out to influence others, becoming woven into local belief systems until their original source was forgotten. This enigma challenges a linear view of history where progress is a straight line from primitive to advanced. Instead, it suggests a tapestry of human intellect where flashes of profound understanding could ignite in different times and places, sometimes in isolation, sometimes through the slow burn of shared ideas. It asks us to consider whether mathematics is less an invention and more an uncovering, a set of eternal truths waiting in the fabric of reality for any curious mind, in any era, to find them. The stones do not tell us which answer is correct. They only tell us that the question itself is written into their foundations, an enduring puzzle about the unity of human thought across the great divides of time and space. The silent language of the past now has a new interpreter, one that sees with laser light and thinks in algorithms. Modern technology has given us a set of keys to the ancient world more powerful than any before, allowing us to scan, map, and model these monuments with a precision their builders could scarcely have dreamed of. This is not about replacing wonder with data, but about using data to deepen our wonder, to move from speculation into the realm of verifiable insight. One of the most revolutionary tools is called LIDAR, which stands for light detection and ranging. Imagine flying a specialized scanner over a dense, impenetrable jungle canopy. The laser pulses penetrate the leaves, bouncing off the ground below and returning to the sensor. what emerges is a breathtakingly detailed three-dimensional map of the terrain, stripped bare of vegetation. Across Central America and Southeast Asia, LIDAR has revealed vast, hidden urban grids, ceremonial complexes, and road networks completely invisible from the ground. It shows us that what we thought was a solitary temple in the wilderness was actually the center of a sprawling, mathematically planned metropolis. This technology rewrites the scale of ancient ambition in a single scan. On the ground, another tool captures the monuments themselves in perfect digital detail. Three-dimensional laser scanning involves projecting millions of laser points onto a surface, like the face of a pyramid or a single carved megalith. The instrument measures the time it takes for each point to return, building a point cloud model accurate to within millimeters. This creates a permanent, perfect digital record of every crack, every erosion pattern, every subtle angle. Why does millimetric accuracy matter? Because it allows researchers to perform analyses that were once impossible. They can calculate volumes and slopes with absolute certainty. They can search for consistent units of measurement across an entire site by testing thousands of potential ratios against the flawless dataset. They can even detect subtle architectural intentions, like the intentional curvature of supposedly straight lines in the Parthenon, a refinement meant to correct optical illusions and create a feeling of perfect straightness to the human eye. With these immense datasets in hand, the next step is simulation. Sophisticated computer modeling acts as a virtual time machine. Archaeoastronomers can input the precise geographic coordinates and three-dimensional model of a site, then run the sky backwards. The software accounts for the slow precession of Earth's axis, showing exactly which star rose over that distant notch in the hills 5,000 years ago, or where the sun set on the temple doorway on the day of its dedication. This allows them to test alignment theories not just for one obvious target, like the summer solstice sun, but for thousands of potential celestial targets across centuries. They can ask the computer to find all significant alignments within a certain range, moving from a guess to a statistically robust pattern. This digital archaeology is our new Rosetta Stone. It transforms the study of ancient mathematical codes from a collection of intriguing anecdotes into a rigorous science. It provides the vast, objective dataset needed to separate human patterns seeking from genuine, repeated intentionality. A theory about encoded Pythagorean triangles in a stone circle can be tested against the laser scan, and the probability of that pattern occurring by chance can be calculated. This process validates some ideas and quietly lays others to rest, steadily refining our understanding. We are no longer just looking at these monuments. We are listening to them with instruments of light, hearing the precise whispers of geometry and alignment that have waited millennia for an audience that could truly understand. The stones did not just speak to the eyes or track the heavens, they were also designed to sing. Beyond the silent codes of geometry and astronomy lies another, more elusive layer of ancient engineering, an acoustic code. This is the mathematics of sound and space, where the very shape of a chamber or the curve of a staircase becomes a precise instrument for shaping human experience. It suggests that for these builders, a sacred space was not complete unless it engaged all the senses, creating an environment where architecture, ritual, and auditory phenomenon were fused into a single, powerful technology. The evidence for this is not merely speculative, it is something you can hear. Within the Great Pyramid, the King's Chamber, built from resonant granite, possesses unique acoustic properties. The dimensions and materials of this room cause sound waves to behave in specific ways. Some researchers have noted that certain low frequencies, perhaps produced by chanting or ritual instruments, could be amplified or sustained within that confined space, creating a palpable, vibrating atmosphere that would have been felt as much as heard. This was not an accident of construction. Granite was a difficult, non-local material chosen deliberately, and its hard, dense nature makes it an excellent resonator. The chamber's shape and volume seem calculated to enhance this effect, turning the pharaoh's resting place into a kind of solid-state speaker, designed to carry a voice or a tone into eternity. Thousands of miles away, at the Mayan pyramid of Kukulkan at Chichen Itza, the acoustic code performs a different kind of magic. If you stand at the base of the grand staircase and clap your hands, the sound does not return as a simple echo. It comes back transformed as a sharp, chirping trill that eerily mimics the call of the sacred Quetzal bird. This phenomenon is caused by the precise geometry of the steps. Each step acts as a sound diffractor, breaking the initial clap into a rapid series of reflections. The timing between these reflections, dictated by the exact height and depth of the steps, creates a cascading audio effect that our ears perceive as a bird's chirp. To achieve this, the builders had to understand, on an intuitive or calculated level, how sound waves interact with repetitive structures. It was an auditory illusion carved in limestone, a permanent miracle where human action could summon the voice of a divine creature. Even the open spaces of megalithic circles may have been acoustic chambers. While the full sonic landscape of Stonehenge is lost to us, studies of other stone circles have revealed fascinating sound properties. The placement of large, flat stones can create reflection zones, while the circular arrangement can focus sound toward a central point or create areas of quiet. This manipulation of acoustics would have been crucial for rituals. A speaker's voice could be carried to a gathered crowd, or the sound of drums might be contained and amplified within the sacred ring, creating an immersive, otherworldly soundscape that separated the ritual space from the ordinary world outside. What does this tell us? It reveals a holistic understanding of environment. These ancient engineers were not just builders, they were composers. They understood that sacred mathematics governed not only what was seen and measured, but also what was heard and felt. They knew that shape dictates sound, and that by controlling space with mathematical precision, they could control experience itself. The chirp of the Quetzal bird was not a decorative afterthought. It was a deliberate audio signature, a proof that the pyramid was alive and responsive to human presence. The resonant chamber was not just a tomb, it was an instrument for altering consciousness. This acoustic layer completes our picture of their coded world. It shows us that their ultimate goal was to design total environments where every element, from the alignment of a doorway to the echo of a chant, worked in concert to guide the mind and spirit toward a specific, profound encounter with the numinous. The monument was not just a message, it was a fully immersive experience. The silent mathematics of form and sound leads to a final, tangible layer, the stone itself. What if the very material chosen for these monuments was the final variable in a grand equation? Beyond geometry and astronomy, some researchers propose that ancient builders selected their stones with a precision that borders on the alchemical, considering not just shape and size, but the intrinsic properties of the rock. This idea suggests a geological code where the mineral content of a block was as calculated as its placement. Take the granite of the king's chamber in the Great Pyramid. This is not ordinary stone. Scientific analysis shows it has an exceptionally high quartz content. Quartz is a fascinating mineral. It is piezoelectric, meaning it can generate a tiny electrical charge when subjected to mechanical pressure, like the immense weight of the pyramid above it. The constant, unimaginable tonnage pressing down on those chamber walls could, in theory, have created a subtle, sustained electromagnetic field within that space. Was this a known property deliberately harnessed, or is it a remarkable coincidence born from selecting the hardest, most durable stone for the pharaoh's eternal chamber? The question lingers, challenging our assumptions about their knowledge of the physical world. This concept of meaningful material extends across the sea to Stonehenge. The smaller bluestones at its heart were not local. They were hauled over 150 miles from the Preseli Hills in Wales. This was not a trivial journey in the Neolithic era. It represents an immense investment of labor and organization. Why go to such extraordinary lengths for these particular stones? Archaeology suggests the Bluestones were believed to have healing properties, and the Preseli area was likely a sacred landscape. The material itself, therefore, carried a significance that transcended mere durability. It possessed a perceived power, a spiritual charge that made the arduous journey necessary. The stones were not just building blocks, they were relics. This line of inquiry naturally ventures into more speculative realms. It connects to long-standing folk traditions and modern theories about ley lines and earth energies, the idea that certain places on the planet possess heightened natural forces. Could the placement of these monuments at specific geographic nodes, using stones with particular resonant qualities, have been an attempt to tap into or amplify these subtle energies? Some propose that the combined effect of precise geometry, celestial alignment, and selected piezoelectric materials was intended to create a kind of architectural technology, a structure designed to interact with both the Earth's field and human consciousness. These ideas, while controversial and difficult to prove with conventional archaeology, point to a holistic vision that we are only beginning to appreciate. They ask us to consider that for the builders, the code was not just intellectual, it was sensory and experiential, woven into the fabric of the material world. The monument was not an inert object but a dynamic instrument, its very substance chosen to complete a circuit between the earth, the sky, and those who walked within its shadow. This ancient dialogue between mathematics and masonry never truly ended. It simply found new voices in new eras, transforming from a sacred language of the gods into a celebrated language of human genius. The great Gothic cathedrals of medieval Europe, those forests of stone reaching for the heavens, are masterclasses in this evolved tradition. Their builders were not merely constructing shelters for worship, they were engineering visions of paradise, and their blueprint was sacred geometry. One key symbol was the vesica piscis, the almond shape created by the overlap of two circles of the same radius. This simple, elegant form was laden with meaning, representing the intersection of the divine and the earthly. You can see its proportions echoed in the pointed arches of doorways and windows, and in the overall floor plans of cathedrals like Chartres. The entire layout, from the nave to the transepts, was often based on a geometric grid derived from these perfect shapes and simple whole number ratios. Even the radiant stained glass windows, which told biblical stories in light and color, were set within stone tracery designed with geometric precision. The goal was not just beauty, but an overwhelming sensory experience. By walking into a space governed by divine geometry, bathed in colored light filtered through mathematically precise windows, the worshipper was meant to feel transported from the flawed, chaotic world into a realm of perfect, heavenly order. The cathedral itself was a sermon in stone and light, preaching the harmony of a universe built on God's mathematical laws. Then, a few centuries later, a revolution in thought consciously reached back to reclaim this ancient wisdom. The Renaissance was at its heart a rebirth of classical ideals, and its architects turned directly to the source. They rediscovered the writings of the Roman architect Vitruvius, who had catalogued the principles of proportion and symmetry used by the Greeks and Romans. Figures like Filippo Brunelleschi did not just read these texts, they performed archaeological surveys of Roman ruins, measuring and sketching to unlock their secrets. Brunelleschi's crowning achievement, the immense dome of the Florence Cathedral, was a triumph of this applied rediscovery. He used a complex herringbone brick pattern and a double shell design, solutions rooted in geometric and structural reasoning that allowed him to span a space wider than any dome built since antiquity. It was ancient mathematical confidence reborn in brick and mortar, And of course, there is Leonardo da Vinci's iconic Vitruvian Man, the drawing that perfectly encapsulates the Renaissance spirit. In that one image, Leonardo visualized Vitruvius's idea that the proportions of the ideal human body could be inscribed within both a circle, representing the divine and the cosmos, and a square representing the earthly and material. This was not just an artistic exercise, it was a philosophical manifesto. It declared that the same mathematical harmony that governed the universe was mirrored in the human form, and therefore should be the foundation of all human creation, from art to architecture to city planning. This direct line from the Parthenon to the Duomo, from the pyramids to the Renaissance palazzo, reveals something profound. The drive to encode cosmic order into physical form is not a relic of a superstitious past. It is a persistent, perhaps innate, thread in human creativity. Each era used the mathematical language it understood to express its highest aspirations, whether for communion with the gods or the celebration of human potential. The stones change, but the silent, harmonious code within them continues to speak. Yet this narrative of a global mathematical language is not without its dissenters, and their voices are crucial to hear. To present only the mystery without the critique would be to build a house on sand. Mainstream Egyptology offers a powerful and grounded counter-narrative. Many scholars argue that the search for hidden codes in the Great Pyramid is a classic case of seeing patterns where none were intended. They point to a far more straightforward explanation, the royal cubit. This was the standard unit of measurement, and the pyramid's dimensions are elegant multiples of this unit. The slope, they explain, was defined by a simple, practical concept called the seek. This was a measure of how many horizontal palms a slope moved outward for every vertical cubit it rose. A chosen seekt, applied consistently, naturally produces a shape with certain proportions. The appearance of a number close to pi, they contend, is a mathematical byproduct of that chosen slope, not the driving intention. It is an emergent property, not an encoded message. The builders wanted a stable, impressive tomb with a specific angle, and the geometry followed. Similarly, at Stonehenge, while the solstice alignment is widely accepted, many of the more complex astronomical proposals are met with skepticism. Archaeologists note that given the large number of stones and gaps, some will inevitably line up with some celestial event purely by chance. Distinguishing between a true, intended alignment and an accidental one requires extraordinary evidence, often lacking when you move beyond the major solar events. This rigorous scrutiny is not an attempt to diminish the past, but to understand it on its own terms, using the tools and priorities the builders themselves documented. Engaging with these critiques is the very heart of the scientific process. It is what separates a robust historical theory from pareidolia, the human tendency to find meaningful patterns in random data, like seeing faces in clouds. A serious researcher must ask, could this pattern have occurred by accident given the number of measurements available? Is there a simpler, more historically attested explanation? This process filters out coincidence and sharpens our focus on what is genuinely remarkable. It forces us to move beyond the seductive allure of a single number and look for a consistent system. Did the builders use this principle repeatedly across different structures? Does it align with other known aspects of their culture, their mathematics, their textual records? By wrestling with these counter-arguments, we do not abandon the mystery. We refine it. We exchange a fog of speculation for a clearer, if perhaps less fantastical, portrait of ancient genius. Their achievement shifts from being about secret cosmic codes to being about the breathtaking execution of a practical, sacred vision using the sophisticated tools they had. This grounded view can be, in its own way, just as awe-inspiring. It means the precision we marvel at was the product of meticulous planning, standardized units, generations of observational knowledge, and an immense, coordinated human effort. The truth may not be hidden in a single number. but written in the collective accomplishment of raising stone to meet the sky on their own profound terms. Perhaps our enduring fascination with these silent stone codes reveals as much about us as it does about them. The magnetic pull of this mystery taps into a fundamental human longing, a deep-seated need to perceive order and intentional meaning in our world. In our modern era, life can feel fragmented, fast-paced, and overwhelmingly complex. Against this backdrop, the very idea that our distant ancestors might have possessed a unified, coherent understanding of the cosmos is powerfully comforting. It presents a vision of a world that made sense, where human endeavor was in direct, harmonious conversation with the mathematics of the heavens. This is not mere nostalgia for a simpler time, but a profound yearning for a lost coherence. It suggests that the chaos we often experience is not the final word, that a deeper, more beautiful order might be woven into the fabric of reality, waiting to be rediscovered. This narrative also delivers a humbling challenge to our modern sense of superiority. We live in an age of staggering technological achievement, of satellites and supercomputers. Yet, these ancient monuments, built with what we consider primitive tools, continue to defy our full understanding and inspire awe. The possibility of a lost wisdom, a different kind of knowledge not rooted in silicon and steel but in stone and sky, quietly questions our assumptions about progress. It asks us to consider that intelligence and insight can manifest in forms we no longer recognize, that a profound connection to natural law might be as valuable as the power to manipulate it. This is why the stones are more than ruins. They are active puzzles, invitations to a grand, collaborative mystery that spans millennia. They transform us from passive observers into active participants. When we study the alignment of a pyramid or measure the proportions of a temple, we are not just learning history. We are attempting to solve a riddle left for us to crack a code that bridges time. This participatory element is incredibly compelling. It fuels both the meticulous work of the archaeologist with a laser scanner and the imaginative leaps of the enthusiast studying star charts. Both are driven by the same essential impulse to connect. We seek a thread, however faint, that links our modern, questioning minds to the intellects that conceived these wonders. We want to glimpse the world through their eyes, to understand what they held sacred enough to encode in everlasting stone. In doing so, we are not just uncovering their past. We are, in a way, searching for a missing piece of our own human story, trying to complete a conversation that began before the first written word. This psychological draw is the engine of the mystery. It ensures the topic endures, evolving with each new tool and each new generation that looks upon these monuments and feels not just wonder, but an irresistible need to listen, to measure, and to understand. The search for universal patterns carries a profound responsibility. As we listen for echoes of pi and phi across the continents, we must be careful not to drown out the unique voices of the cultures that raised these stones. This is the ethical dimension of the mystery, a necessary pause in our decoding to ask not just what the numbers mean, but whose mathematics we are using to hear them. There is a significant risk in viewing every ancient structure through a purely Western, Greco-Roman mathematical lens. For instance, to analyze a Mayan pyramid primarily for the golden ratio might cause us to overlook its true genius, a design deeply rooted in their own sophisticated base 20 numerical system, and their sacred calendar cycles of 260 and 365 days. Their code was not written for our geometry textbook. It was written for their cosmos, one where time itself was a deity measured in precise, repeating rounds. Imposing our framework without this cultural context is like translating poetry using only a dictionary. You might get the words, but you will certainly lose the rhythm, the metaphor, the soul of the piece. The stones are not neutral objects for our intellectual puzzles. They are often sacred sites, central to the living heritage and identity of descendant communities. For them, a pyramid is not a riddle to be solved. It is an ancestor, a teacher, a place of profound spiritual continuity. Our fascination must never become a form of intellectual colonization, where we arrive with our calipers and software to extract a universal secret we find pleasing, while disregarding the specific, culturally rich meanings that give the place its true power. This respect extends physically. Increased global interest can place fragile sites in jeopardy, from the erosion caused by thousands of footsteps to the threat of looting or irresponsible speculation that prioritizes a dramatic theory over preservation. Ethical decoding, therefore, is a collaborative act. It involves partnering with archaeologists, anthropologists, and most importantly, the cultural representatives and knowledge keepers for whom these monuments are not ruins, but a living chapter of their story. It means humbly acknowledging that our search for a global mathematical language should not erase the beautiful, distinct dialects in which it was spoken. The ultimate goal is not to claim these codes for ourselves, but to understand them as their builders intended, ensuring our curiosity honors both the monument and the memory of the hands that built it. The mathematical codes of the past are not a closed book, but a story still being written. Every year, new chapters are unearthed, often in places we least expect. Deep within the Amazon rainforest, LIDAR technology has peeled back the green canopy to reveal the ghostly outlines of vast, interconnected settlements, complete with geometric earthworks and ceremonial plazas. These pre-Columbian cities, hidden for centuries, are not just archaeological discoveries. They are brand new datasets, fresh pages of an ancient manuscript we have only just begun to read. Each new site offers a unique opportunity to test our theories. Do these newly found complexes in the Amazon also align to solstice sunrises? Do their plaza dimensions reflect sacred numbers or standardized units of measure? Every fresh discovery provides another point on the global map, allowing us to see if the patterns we have observed are truly universal or wonderfully distinct cultural expressions. The ground beneath our feet, it seems, still holds countless untold stories waiting to join the conversation. To read these new pages, we will need more than shovels and brushes. We are on the cusp of a technological revolution that will allow us to listen to these stones without ever touching them. One of the most promising new tools is called muon tomography. It sounds like science fiction, but it is grounded in cosmic reality. Muons are subatomic particles that rain down on Earth from outer space, passing through solid matter. Dense materials, like the stone of a pyramid, absorb more of these particles than empty space. By placing sensitive detectors around a monument, scientists can create a three-dimensional image of its interior density, much like a medical CT scan but using cosmic rays instead of X-rays. This means we could peer into the heart of the Great Pyramid or any other massive structure, searching for hidden chambers, internal voids, or structural features that have been sealed for millennia. The very cosmos becomes our X-ray machine, offering a non-invasive key to unlock secrets we have only guessed at. Alongside this cosmic vision, another powerful tool is learning to see patterns invisible to the human eye. Artificial intelligence, trained on the immense datasets we are now collecting, could become the ultimate codebreaker. Imagine feeding a global database of architectural measurements, alignments, and proportions into a sophisticated learning algorithm. This AI would not be swayed by human bias or the desire to find a favorite number. It would coldly, methodically search for correlations and repeating mathematical relationships across continents and cultures. It might identify a common unit of length used in sites we never thought were connected. It could detect subtle alignment patterns to specific stars that a human researcher focused on the sun might have overlooked. This technology could sift through the noise of millennia to find the true signal, separating universal architectural principles from fascinating coincidence with unprecedented rigor. The promise of the next decade is breathtaking. We stand at a unique moment where discovery and decoding are accelerating in tandem. Each new LIDAR scan of a jungle, each muon image of a pyramid's core, each pattern recognized by artificial intelligence brings us closer to a fuller understanding. This technological leap may finally allow us to confirm some of our boldest hypotheses about encoded knowledge, but perhaps more exciting is the certainty of surprise. These tools will undoubtedly reveal entirely new layers of meaning, geometries we have not yet thought to look for, and connections that rewrite the map of ancient intellectual exchange. The silent stones have held their secrets for thousands of years. Now, for the first time, we are building the tools that might allow them to speak in complete sentences. The next great revelation in this ancient mystery may not come from a dusty excavation trench, but from a stream of data, a cosmic particle, or the quiet hum of a machine learning to read the world's oldest blueprints. These diverse threads of evidence from geometry to geology weave together into a single, profound tapestry. We can now propose a unified theory of the ancient monumental code. This was not a single secret, but a holistic system where science, art, and religion were inseparable expressions of one worldview. Mathematics was the core language of this system, a versatile tool serving multiple, simultaneous functions. First and foremost, it was practical engineering. The consistent use of Pythagorean triples, standardized units like the royal cubit, and principles of load distribution were not mystical. They were the indispensable tools that ensured a pyramid would not collapse, a lintel would stay level, and a temple would stand for millennia. This mathematical rigor was the bedrock of all that followed. Upon this stable foundation, the code served as a celestial calendar. By encoding solstices, lunar cycles, and star risings into alignments, the monuments became giant, permanent clocks. They marked the passage of seasons, dictated the timing of planting and harvest, and scheduled sacred ceremonies, weaving the rhythm of the cosmos directly into the rhythm of daily life. But the purpose soared far beyond utility. This same mathematics was a living theological text, the proportions echoing the golden ratio, the shapes of circles and squares, were believed to be the divine blueprint of creation itself. Building with these forms was an act of participation, an attempt to bring human space into harmony with cosmic order and to create a dwelling place worthy of the gods. Finally, this code was an unwavering artistic canon. It defined the proportions that the human eye and spirit find inherently beautiful and awe-inspiring. The sweep of a pyramid's slope, the rhythm of a temple's columns, the overwhelming scale of a processional avenue, all were calculated to elicit a specific emotional and spiritual response, to humble the individual and elevate the community. This multi-layered coding system achieved something extraordinary. It transformed inert stone into a transgenerational hard drive. In a world before widespread literacy, where knowledge was vulnerable to the passing of oral traditions, these civilizations found a solution. They stored their most vital collective knowledge, their understanding of mathematics, astronomy, philosophy, and their place in the universe in the most permanent medium they could conceive, the very landscape. The monument became a library, a school, and a temple in one, designed to speak its lessons across centuries to anyone who learned to read its silent, numerical language. The silent stones have spoken their final, most profound lesson. Our journey through the coded foundations of the ancient world reveals an intellectual landscape of breathtaking sophistication. These recurring patterns, from the pi in the pyramids to the phi in the Parthenon, are not random artifacts of construction. They are the deliberate fingerprints of a unified vision, the legacy of master builders who understood mathematics not as an abstract study, but as the sacred bridge between the earthly and the celestial. While scholarly debates over specific alignments and interpretations will rightly continue, the cumulative weight of evidence points to an undeniable truth. Across continents and centuries, our ancestors developed and spoke a shared language. It was a vocabulary of geometry, a grammar of astronomy, and a syntax of perfect proportion. They used this language to encode their deepest understanding of cosmic harmony into the very bones of their greatest achievements, transforming stone and space into a permanent library of human insight. This enduring puzzle does more than challenge our historical timelines. It challenges our modern sense of connection. In our relentless pursuit of the new, we may have forgotten an older, more holistic way of knowing, one that saw number and nature, temple and sky, as parts of a single, magnificent equation. Perhaps our drive to decode these monuments is about more than solving an ancient mystery. It is a search for a missing piece of ourselves, a longing to recover that innate sense of wonder and our place within a beautifully ordered cosmos. The stones stand as silent mentors, reminding us that the capacity to perceive this profound order is a fundamental thread in the human story. If this exploration has reshaped how you see the quiet ruins of the past, we would love to hear your perspective in the comments below. Subscribe to join us as we continue to unravel the deepest mysteries, listening for the next whisper from the ancient world.